So our next topic is going to be absolute values and fractions in inequalities. So absolute value, again, our good friend absolute value, we see it in every chapter, as you remember, is a value that describes the distance between the number and the origin and number line. Absolute value has two cases. We have a for the positive numbers, and we also can have a negative term for all a's smaller than 0. So when we deal with absolute values in inequalities, we also deal with two different cases. This is a general form how it can look in inequalities. For example, we have term x plus 4. This is absolute value of two terms, x plus 4 and negative term of x plus 4, which is x plus 4. 4 minus x minus 4. And this will be true if x plus 4 is larger than or equal to 0. And this case is if x plus 4 is smaller than 0. Or we can also write it like if we move 4 here, if x is larger than minus 4, or if x is smaller than minus 4. So when dealing with absolute values, we will have always distinguished two cases. Our final stop today are fractions in inequalities. When we have inequality with fractions, which variables are in denominator, there could be two situations. First, when we do not change any sign of inequality. Let's look at this example. So the denominator of this inequality is positive for all real numbers. So if we multiply both sides of inequality by x squared plus 1, so here will be x squared plus 1 less than or equal to 2. And if we move 2 to the other side, we will end up with this inequality. Multiplying both sides to this term will give us this equivalent inequality. The quadratic equation x squared minus 1 has two solutions, x equals to 1 and x2 equals to minus 1. The solution set of this inequality will be between those roots. So we now deal with this inequality here, and again we always can check which intervals of our inequality can fulfill. And if we look here, only here is our solution set, because in all other cases we will have something larger than 0. Next example, when we change the sign. So here we have a denominator which is a little bit problematic. Because denominator cannot be equal to 0, we have to exclude the root of this term. So we have to look at two situations when x is larger than 1 or x is smaller than 1. So for x, when x is less than 1, if we multiply both sides by 1 minus x, we will get, and it means that solution set will lie x greater than 2 divided by 3 for all x smaller than 1. If we take the second situation for x larger than 1, if we look at the denominator, for everything that will be larger than 1, we will get negative number. And when we multiply by negative term, we change the sign. because again, for every x that's larger than 1, our denominator will be negative. And if we multiply both sides by negative term, then we change the sign. Here we'll take 3, 1 minus x, and we will end up with something like x less than 2/3. So we have two different cases. First for x smaller than 1 and for x larger than 1, because we want to exclude the case when denominator equals to 0, because we don't want that. Now we have to look at the two cases separately. I will write it 1 and 2. For the first case, we have x less than 1 and x greater than 2/3. So we look at the number line. We will have empty points because we don't have an equal sign here. We have 2/3 here and 1 here. So our x needs to be greater than 2/3, but at the same time smaller than 1. So solution set will lie in this interval. So x will be somewhere between 2/3 and 1. So this is solution set for this case. And for the second case, we also write it down. X bigger than 1 and x smaller than 2/3. Again, we will have two empty points, 2/3 and 1. So we want everything less than 2/3, but larger than 1. So we don't have any intersection here, and thus no solution here, because these two inequalities, they contradict each other. Thus, our solution set will be the interval between 2/3 and 1 only. Today we had not very easy topic. It was complicated, but I hope it got a little bit better. Please have a good rest. Do some exercises and homework. With the practice, everything will be clear, and the more examples you will have, the better. We are moving to a very interesting topic for the next chapter. See you there.